All right, so hello again, everybody. It's just great to be here. And today I have the absolute privilege of giving a talk, really more of a primer on software bills of material as a solution in the software supply chain. So just to get started, first we got to ask ourselves, what exactly is the software supply chain? What do we mean by that? Well, in the simplest terms, it's really just all the different software components that are brought together and combined to make our final software products. Now, with modern software development, it's not very common that you're going to make the entire thing in-house. Instead, we're going to be leveraging open source. So you're going to be getting code from somewhere else. Maybe you're pulling it from a repository or a forge. Maybe you're getting it from a package manager. Maybe you're getting it from some code sharing site like Stack Overflow or something. It doesn't matter. And we do this because it makes software development easier, faster, and smoother, because we don't have to constantly be reinventing the wheel. But it's not all sunshine and lollipops. There's going to be some problems that occur when we're doing development this way. The first and most foundational of which is just dependency management. The question you want to ask yourself here is, what is in your project? For a small little toy project, something that you're just doing on your own, this isn't too hard to answer. You can pretty readily keep track of everything that you've imported, right? These would be called your direct dependencies. But this can get more difficult as a project scales and gets larger. If you're working on a project that's existed for many years, maybe you've got dozens of developers, you've got hundreds of developers, the likelihood increases that somebody might not have documented something that they're using. Also, institutional knowledge could get lost as people are coming and going from the project. But what's really difficult about dependency management is something called a transitive dependency. And those are really just the dependencies of your dependencies. So if you're using something in your project, you might be relying on many, many other things that you're not even consciously aware of unless you go looking for them. An example of this that many of you have probably used before would be like machine learning. If you did TensorFlow or PyTorch, that would be your direct dependency. But those libraries rely on libraries like NumPy, so that would be a transitive dependency. Also, if you've ever done a pip install, which I'm guessing everybody has, when you install that module, notice it has all those requirements listed that it also installs. Those are your transitive dependencies. Now, this is important for two main reasons. The first of which is the exciting world of license compliance. So every single one of those dependencies that we've talked about, even the ones you might not know that you have, is going to have a different software license. They fall into two broad categories. They can be permissive, basically meaning you can do whatever you want with the software as long as you give attribution, or they could be copyleft, which means that any derivative works need to be licensed in the same way, and they need to also be made open source. But why does that matter? Why do you need to know what licenses are there? Well, because you need to make sure that you comply with all those terms. People have let you use their software for free, given that you give them attribution, you license the same way, whatever. So your project's license needs to make sure that it's compatible and complies with all of these dependency licenses. Otherwise, you could be opening up the door to a world of hurt, which looks like legal liability, could be financial loss, or it could be reputational damage for you or your client, your company. Now, the second reason that you should care about what's in your project, this is probably arguably the more important one, at least in most of our minds, would be security concerns. If there's any kind of an exploit in any of your dependencies, could be a direct dependency, could be a transitive dependency, it doesn't matter. That could potentially leave your project open to attack as well. An attacker could go through that vulnerability to get to you. It's not a guarantee that that's going to happen, but it's a possibility. This has also opened up supply chain attacks, which I'm sure you've heard about in the news, where a bad actor in an attempt to target you or your project, which might be really secure. Maybe it's like Fort Knox, you've done your due diligence. But there's a wider attack surface, and they'll go for that weakest link dependency so they can get to you. Just to motivate this a little bit more, in 2022, supply chain attacks impacted over 10 million people and 1,700 organizations. Some recent examples that you'll probably recognize are the SolarWinds breach, the Log4j critical vulnerability. So what's the solution? What can we do about these problems? Well, as you might have guessed from the title of this presentation, SBOMs offer a really good solution here. SBOMs standing for Software Bill of Material. And really, in a nutshell, you can think about these as the nutrition fact blocks on a piece of food. Just like how these nutrition facts tell you the ingredients that's in what you're going to eat, an SBOM is going to tell you all the different components and dependencies that are in a different software build, as well as like provenance information. So not just the dependency, but also where did you get that dependency from? Did it come from a GitHub repository? Did you get it straight from the package manager? Did you get it from some decade-old Reddit thread? Where did it come from? And it also includes that licensing information that we talked about before. Now, bare minimum, these files need to be machine readable, but ideally they should also be human readable. But that gets to be a little bit more difficult as the projects get larger because these documents get really, really long and they can become hard to parse. And currently there's two main standards for SBOMs. There's SPDX and Cyclone DX. Unfortunately, we don't have time to dive into those differences, but talk to me after. So all this sounds great. Sounds like we've already got a solution to this problem. So where are the research opportunities here? Well, there's still quite a few major stakeholder concerns. Of these, we've got uncertain or low levels of commitment to SBOM. And a lot of this is coming from the uncertainty of whether or not SBOM benefits are going to be actualized, or if they're just going to become another piece of documentation, another box to tick, just another piece of bureaucracy that's not actually giving any benefit to the developer or the project. There's also fears of inaccurate and incomplete SBOMs. If you take a moment and think about it, having an inaccurate or incomplete SBOM might be worse than not having an SBOM at all. It's going to give you a false sense of security. There might be some alert that goes out and says, this package is vulnerable. If you have it, make sure you update it. And if your SBOM is not accurate, you might think that you're safe and then you don't do your due diligence. And then another one would be a lack of mature tool support for consumption and production. And this really varies from language to language and from ecosystem to ecosystem. But if there's not good tools, then there's not much you can do with them even if you have them. So we boiled all these concerns down to three main research questions. How do software stakeholders create and use SBOMs? What are the challenges of creating and using SBOMs? And what are actionable solutions to SBOM challenges? To answer these at a very high level, we contacted developers from these 5 different groups you can see here on the screen. Of those, we got 84 valid survey responses, and we conducted 8 follow-up interviews. Doing this, we were able to identify these 14 challenges, which I obviously do not have time to talk about in detail now, but please do come to my poster later if you're interested. And we proposed 6 actionable solutions that can address those 14 challenges. So I don't know if we have time for questions, but I'd be happy to take any later today.